So in this tutorial, we will discuss linear programming problems from class 12th, right? Linear programming. Problems. In short form, it's called LPP. This is a very important chapter for CBSE examination only, for long answer type question. In linear programming problems, you must need a graph paper to solve each and every question, right? There are three types of problems can be asked. First one is manufacturing problem, second one is diet problem, and third one is transportation problem. So first we are going to discuss about the manufacturing problem, first topic. There are three different steps to solve each and every question. First step, we need to write some linear inequalities. Second, to draw the graph and set the region of that linear inequality. And third, to find the corner point and find the maximum or minimum value of the function, right? So there are three important parts. We will discuss these things with an example. If we have a question like a manufacturing company takes two models A and B of a product. Each piece of model A requires 9 labor hours for fabricating and 1 labor hour for finishing. Each piece of model B requires 12 labor hours for fabricating and 3 labor hours for finishing. For fabricating and finishing, the maximum labor hour available are 180 and 30 respectively. The company makes a profit of rupees 8,000 on each piece of Model A and rupees 12,000 on each piece of model B. How many pieces of model A and model B should be manufactured per week to realize a maximum profit. And what is the maximum profit per week? What is the maximum profit per week, right? A manufacturing company takes two models of a product. For example, a company makes two types of shirts, type A and type B. Each piece of model A requires 9 labor hours for fabricating. Each piece requires 9 labor hours for fabricating and 1 labor hour for finishing. And each piece of model B requires 12 labor hours for fabricating and 3 labor hours for finishing. For fabricating and finishing, there are the maximum labor hours 180 and 30 per week respectively. The company makes a profit to be 8,000 each piece of model A and 12,000 each piece of model B. Right? How many pieces of model A and B should be manufactured per week to realize a maximum profit? First, we need to write some inequality. Right? So first we have to consider two variables in this. Let us see how many pieces of model A and model B should be manufactured. So we can consider, let the number of pieces of model A be X and the number of pieces of model B be Y. Right? Now according to the question, first we need to write the inequality. We can draw a rough diagram. Model A, model B, fabricating and finishing. Right? Model A requires 9 hours fabricating and 1 hour finishing. Model B requires 12 hours and 3 hours for finishing. And for fabricating and finishing, maximum labor hours available is 180 and 30. Maximum labor hour available. Maximum means less than equal to 180. We have less than equal to 180 hours. We have less than equal to 30 hours for finishing, right? And you know the number of pieces of X and number of pieces of B, Y. And after that we have the profit 8,000 on model A, profit, and 12,000 on model B. We need to write some inequality. First of all, we can say that if one piece is 9 hours and one piece of product B takes 12 hours. So first inequality will be 9x plus 12y is less than equal to 180. 9x means what? If you produce x unit of product A, so 1 unit will take 9 labor hour for fabricating, so x unit will take 9x labor hour for fabricating, and y unit of B takes 12y hours for fabricating. And the total fabricating hours is maximum 180, means this must be less than equal to 180. Now The second inequality will be x plus 3y less than equal to 30, and we can also say x is greater than equal to 0 and y greater than equal to 0. Why? Because x and y are the quantity that cannot be negative. That's why you can take x is greater than equal to 0 and y greater than equal to 0. And what about the profit function? Profit function is called z, which we have to find. We have to find the maximum profit, and we have to find the value of x and y for the maximum profit. This we have to maximize the constant profit. Profit will be 8,000x and plus 12,000 y. We need to maximize or minimize these things. Maximize only. Find the maximum profit, and at which point, how many quantity we produce for x, a and b to get the maximum profit. Right? Now we need to draw the graph for this. First we need to draw the graph for this. Right? We can simplify the first inequality. After cancelling 3 both sides, we will get 3x plus 4y is less than equal to 60. So first of all, we have to draw a diagram, a graph for this. We have to draw the graph, and you need to draw the graph on the graph paper only. Right? So first of all, we have to draw the straight line for 3x plus 4y equal to 60. If you take y equal to 0, x equal to 20. And if you take x equal to 0, y equal to 15. So this may be a straight line. And this straight line passes the point y-axis at 0, 15 and x-axis at 20, 0. Right? And this is called 3x plus 4y is equal to 60. Second, x plus 3y equal to 30. If we take y equal to 0, x becomes 30. X becomes 30. This one is 30. And if you take y equal to 0, x equal to 0, y becomes 10. So this would be the second straight line, this one. And it passes to the point 0, 10 on y-axis and 30, 0 on x-axis, right? And the third inequality, x is greater than equal to 0. What do you mean by x is equal to 0? This is straight line. Y-axis is called x equal to 0 and x-axis is called y equal to 0. Right? Now we have to set the common region of all the 4 inequalities. First one, 3x plus 4y less than 60. Less than means towards origin. Towards origin. X plus 3y less than 30 means towards origin. X is greater than equal to 0 and y greater than equal to 0. What is the common region with all the 4 straight lines? This is the common region. With all the 4 inequality, this is the common region. Right? So first we need to find the common region. Second part is over. First part to write the inequality with z. Second part to draw the graph of that inequality and set the common region. And the third part, we need to write the corner point and draw the corner point table. Corner points. We need to draw the corner point table. Corner point and z, which is 8000x. We have to find the value of z at every corner point. So you can see the shaded region. There are 4 corner points: O, A, B, and C. 4 corner points are there. The coordinate of O 0, 0. Coordinate of A 20, 0. Coordinate of B. If you draw this graph on the graph paper, you can see, you can observe the point B, right? Now we have to find point B. So B is the point of intersection of these two straight lines, and this straight line is x plus 3y equal to 30. We need to solve this equation to find this. So in rough paper, we can solve 3x plus 9y is equal to 90 and 3x plus 4y is equal to 60. So you can cancel this one. 5y is equal to 30, then y is equal to 6. If you put y is equal to 6 in this, 60 is 18, so x is equal to 12. So 12 comma 6 is this point. Right? And the fourth corner point C is called 0 comma 10. So these are the corner points. There are 4 corner points in this shaded region, in this common region, right? Now we have to find the value of z in each point. This and this point may be the point of maximum profit. So let's see how to find the maximum profit. We can put here 0, 20 comma 0. So 8,000 multiplied 20, 1,60,000. 12, 96,000 plus 6 multiplied 12, 72,000. We'll get 0, 0, 0, and this is 1,68,000, and the fourth one 0 comma 10 will be 1,20,000. We need to put the value of x and y in the place of x and y z. We'll get the value of z. Now see, we have to find the maximum profit. So what is the maximum profit here? 1,68,000. And at which point we have maximum profit? At point 12 comma 6. Means when this manufacturing industry produces 12 unit of product A and 6 unit of product B, then they get the maximum profit 1,68,000. Right? So we can say that this is the maximum. So therefore, the manufacturer produces 12 units of product A and 6 units of product B to get the maximum profit of rupee 1,68,000. To get the maximum profit of rupee 1,68,000. Right? This is the maximum profit. We have two questions in this question. In this, how many pieces of model A and model B should be manufactured per week to realize the maximum profit, and what is the maximum profit? So we got both the things. Not a product A, this may be model A of same product, model A and model B. Right? In each and every manufacturing type problem, you need to do same thing. First part, to write the inequality. Second part, draw the graph, and third part, draw the corner point table. In some graph, you may find the common region or the shaded region is unbounded. When it will be unbounded, the concept is somewhat different to solve this, right? And you will get the unbounded region in that problem, second problem, right? Now we will do one more question related to manufacturing problem. Second question we have. Let's see, we have one more question. Yes. The question is, a merchant plans to sell two types of personal computers. Two types of personal computers, a desktop model and a portable model. That will cost rupee 25,000 and rupee 40,000 respectively. He estimates that the total monthly demand of computers will not exceed 250 units. Determine the number of units, determine the number of units of each type of computers which the merchant should stock to get maximum profit. If it does not want to invest more than rupee 70 lakh and his profit on the desktop is rupees 4,500 and on the portable model is rupees 5,000. Make an LPP and solve it graphically. This question already asked in 2011 board examination. A merchant has to sell two types of computer model. First one in desktop and second one in laptop. In desktop, the cost of each desktop model is 25,000 and the portable model is laptop model 40,000. And he estimates the total monthly demand of computer will not exceed 250 units. Altogether both desktop and laptop. Determine the number of units of each type of computers which determine the number of units of each type of computers which the merchant should stock to get the maximum profit. Everything clear from these two lines. First, we have to consider two variables here. First, let the number of desktop model be X and the number of portable model be Y. Number of desktop model be X and the number of portable model be Y. Now, the question is, what is the cost? 25,000 and 40,000, and the merchants estimate the demand will not exceed 250. Means you can say that according to the question, X plus Y should be less than equal to 250. Demand will be less than equal to 250. Total demand of X and Y. Not more than that. Not exceed. Will not exceed 250. Means less than equal to 250. Right? And the merchant does not want to invest more than 70. Not want to invest more than 70 lakh. Means he need to invest less than equal to 70 lakh. He has 70 lakh only. So the cost 25,000 X total on the desktop model purchase and 40,000 Y in the portable model purchase should less than equal to 70 lakh. Second inequality. And third, X is greater than equal to 0 and Y is greater than equal to 0. Why? Because X and Y are the quantity and they cannot be negative. And next one, to find the maximum profit, we need to write the constant Z, which is profit function. The profit function, you know, the profit is 4,500 on each desktop model, means the total profit to sell the desktop model is 4,500X and 5,000Y. Right? 4,500X plus 5,000Y. This is a constant Z. Now, when we can simplify this one by cancelling 3 zeros, 3 zeros, 3 zeros and 3 zeros, we can cancel with 5. We will get 5x plus 8y is less than equal to 1400, right? So now we have two important inequalities. The second part, we need to draw the graph for the inequality. Then we can find the maximum profit. There are two types of questions can be asked in this topic. First one, to find the maximum profit, and second one, to find the minimum cost. Either to find the maximum profit or to find the minimum cost. In the case of to find the minimum cost, we need to minimize that cost function. In the case of maximum profit, we need to maximize the profit function. Now let's see how can we draw the graph for the inequality. We have coordinate axis X and Y, positive and negative with origin. And first of all, X plus Y is equal to 250. This is the straight line which passes through 250, 0 and 0, 250, right? And this straight line is called X plus Y is equal to 250. Second, if you take Y is equal to 0, X will be 280. X will be 280. And if you take X equal to 0, Y will be 1400 by 8. It should be 350 by 2, means 175, right? So we need to draw the second straight line as this one, second straight line. Yeah, this is the straight line. You should draw the graph on the graph paper, and this will be 5x plus 8y is equal to 1400. This point is called 0, 175. Right? Now, x is greater than equal to 0, this is x equal to 0 and this is y equal to 0. X axis is called y equal to 0 and y axis is called x equal to 0. Now, here we have less than, so less than means this one. Again less than, x is greater than 0, y is greater than 0. This should be the common region. This should be the common region. This should be the common region. Now we have to draw the corner point table. Corner point table, and z is equal to 4500x plus 5000y. Now you can see the corner points O, A, B and C. You can write O as 0, 0, 250, 0. You can say the B and C at 0, 175. By observing the graph paper, you can say the coordinate of point B. Right? So now you can solve this to find the Z for points A, O, B and C. Whichever is maximum, that is the maximum point. And now you will get the maximum profit, and at which point you will get the maximum profit. Right? So these are all about the manufacturing problems. Now you can solve each and every question related to manufacturing problem. Right? Now in the next tutorial, we will discuss about the diet problem and the transportation problem. You need to solve each and every question from NCERT also and previous year board examination based on manufacturing problem. Thank you.